Welcome you all for the today's session on types of virtualization. In today's session, we are going to see about the server and network virtualization. So the virtualization, it is the very powerful tool that drives significant benefits for cost, flexibility, and the environment. There will be different types of virtualization types, include server virtualization, network virtualization, storage, desktop, application, and management. So first, let us understand what is meant by virtualization. So imagine you're going to buy a large apartment with 10 rooms, but only you're going to use only one room. The remaining 9 rooms are going to be empty and it's going to be wasted. So in many organizations, a powerful server is going to be purchased, but only a 15 to 20% of its capacity is going to be used. So this leads to a wasted hardware. There will be high electricity cost will be there. The maintenance cost also will be very high. To solve these problems, we are going for this virtualization concept. So this is the diagrammatic representation of the types of virtualization, which include server virtualization, storage virtualization, desktop, presentation, application, and those everything can be managed by the managed virtualization. So let us start the first virtualization. The first one will be our server virtualization. So it is the most widely used virtualization techniques in corporates. So server virtualization, it is the process of dividing one physical server into multiple virtual servers. You're going to divide that into multiple virtual servers. Each and every machine can act as an independent computer. So for example, there will be 10 machines or there. You're going to convert that into 10 virtual servers. So each and every machine contains its own operating system, its own CPU allocation, memory allocation will be different, storage will be different. It contains different kinds of applications, and we can able to have a different OS. It should not be an same operating system. For example, a company can own, for example, it may be on a 2 GB of RAM size, it may be on 128 GB of RAM, 32 CPU core processor, 2 TB of storage, it may 256 GB of storage. So each and every machine is going to be differ. So all the each and every machine can operate in a different manner, that is an independent one in server virtualization. The example for the server virtualization, it includes Ubuntu Linux. One virtual machine is using Ubuntu, the another one is working on Windows, the third one is working on Red Hat Linux. So before server virtualization, we are going to have only one physical server. That physical server is going to operate only for a specific application. So what is the result of using this physical server means? A result will be in low utilization. It requires more electricity. The maintenance cost will be very high. The hardware cost of the server also will be very high. Whenever we are using this server virtualization, one server can run with many applications. So automatically, so there will be a better utilization will be there. The cost is going to be reduced. Then the deployment cost also will be very fast. So we all know that the heart of the virtualization will be a hypervisor. The hypervisor is the most important component of virtualization. So the hypervisor is nothing but it is a software that creates and manages the virtual machines. So automatically the hypervisor is going to allocate the CPU, it is going to allocate the RAM, storage and network as usual, that is CNS. So C stands for computation, N stands for network and S stands for storage. The same process of your cloud computing. So think the best real-time example of hypervisor is you can think it is a traffic police officer. So how he is directing the vehicles at a busy intersection. Yes? So just like that, we are going to allocate a different CPU, different memory, different storage, and then different network resources for each and every virtual machines. So again, your server virtualization is classified into 3 types. So one will be a full virtualization, the second one will be a para virtualization, and third one will be a OS level. In full virtualization, there is each and every virtual machine that is completely independent computer. Okay, so there will be no any guest OS will be there. It does not require any virtual thing. So the hypervisor is going to control everything in full virtualization. Okay, so this is the high isolation will be there. The security also will be very high. It is going to support different kinds of operating systems. The best example for this full virtualization will be your VMware workstation, Hyper-V, then Oracle VirtualBox. We are going to discuss the next type of virtualization, that will be a para virtualization. So in this para virtualization, basically it is used for improve the performance. So here we are going to use the guest OS. So you can consider in the full virtualization we are not going to use any guest OS. Only the host OS is going to be used. But in para virtualization we are going to use the guest OS. So here we are going to communicate directly. That is, there will be a direct connection. That is direct connection or communication between the hypervisor. So while we are using, it's a direct communication, so automatically there will be a less processing overhead. The speed also will be very high. The third virtualization will be your OS virtualization. So OS virtualization means this type, it does not require any hypervisors. Okay, OS virtualization, it does not require any hypervisors. Instead of hypervisors, this OS virtualization, it contains the containers. So containers means it is automatically, it is going to create an multiple isolated environments. So all containers can share the same operating system kernel. There will be a kernel is the heart of your OS. The same kernel is used for the different application. The diagram shows, for example, there will be in 3 guest OS or there in a virtualization application. The same thing is used for all the applications. So the best example for OS virtualization are Docker containers, OpenVZ, LXC and all. So the real-time example will be, or you can imagine it's an apartment building. That is each and every family or living in a separate apartment, but everyone is sharing the same building. The apartment is same, but the rooms are going to be different. As like that, or the operations are going to be different in virtualization, but the kernel is going to be the same. So that will be your OS virtualization. So here we are going to concentrate only on the host OS. The next thing will be a server virtualization. So server virtualization, it is mainly used for cost reduction in infrastructure. It is going to increase the efficiency. It is going to increase the security. Most probably, the server virtualization, it is mainly used in the startups in order to reduce the cost. The key features of the server virtualizations are multiple virtual servers can run on one single physical server. Multiple virtual machines is isolated from other virtual machines. We are going to allocate CPU, RAM and storage in a shared efficiently. So most probably this network virtualization, or also it is going to be a time consuming process. It is going to improve the productivity. It is going to sharing and reallocation of storage space also will be possible here. This is a diagrammatic representation of your network virtualization. In network virtualization, you are going to use either you can use external or you can use this internal. So most probably internal network virtualization is preferred because most of the systems are using Zen or KVM processors. So these are the references of the today's session. Thanks for joining us. Thank you.